Solve the following equations. Show all of your work. Graph your solution on a number line. So I'm going to add 6 to both sides. Oh, subtract 6 from both sides. So I get 5x equals 25. Then I'll divide by 5. X equals 5. Here I'm going to add 3 to both sides. I get 20 equals 4m, divide by 4, and I get m equals 5. Here I'm just going to divide by 3 on both sides since I'm multiplying by 3. Those cancel, and I get 2w minus 3 equals 11. Then I can add 3, 2w equals 14, and divide by 2, w equals 7. Here, because I'm not multiplying by anything, I can get rid of my parentheses, but I can do what's inside of them. So 9x minus 3x is 6x. Subtract 4 from both sides, and I get 6x equals 30. Divide by 6. 30 x equals 5. Here I'm going to distribute the 5. So I get 7a plus 5a minus 10 equals 14. 7a plus 5a is 12a. Combine my like terms. Then I'll undo subtracting by adding. 12a equals 24. Divide by 12. And a equals 2. For the following problem, write an equation with defined variables and solve. Be sure to write your answer in a complete sentence. So Alex bought 3 bottles of soda and a bag of chips. The chips cost $3 and the total purchase was $9. How much did each bottle of soda cost? Let the variable b represent the number of bottles of soda. So he bought 3 bottles of soda, so we'll have 3b, because that's for the number of bottles of soda, plus 1 bag of chips, which was $3, so plus $3 equals $9 for his total purchase. So then we can subtract 3 from each side, and we get 3b equals 6, divide by 3, b equals 2. So each bottle of soda was $2. Change the following equations into y equals mx plus b form, then graph them on the axes provided. So first I need to get rid of this 2x. So I get 3y equals negative 2x plus 18. Divide by 3 on both sides. And I get y equals negative 2/3 x plus 6. For this one, I need to distribute the 4. So 4x plus 4y equals 16. Then I'm going to subtract the 4x, move it to the other side. So I get 4y equals negative 4x plus 16. Divide by 4 on both sides. Y equals negative x plus 4. So now I need to graph them. So this will be line A. This will be line B. So line A has a y-intercept at 0, 6. So I go up 1, 2, 3, 4, 5, 6. And its slope is negative 2 over 3. So I go down 2 and over 1, 2, 3. Down 2, 1, 2, 3. This is line A. Line B has a y-intercept of 4. So I go up to 0, 4. And my slope is negative 1. So I go down 1 over 1. This is line B. Write your own example of a linear, exponential, and quadratic pattern. Complete the table for each pattern, then sketch a graph of the pattern. Explain how you know that each pattern is linear, quadratic, or exponential. So my linear pattern, I'll just start with 0, and I'll add 5 each time. So I went up 5 every time. So my first difference is constant. So a sketch of this, see when x is 1, y is 0, so that's like right here, and it goes up by 5, so it would look like that. For an exponential pattern, I know that I want to multiply by the same amount every time. So I'll start at 1, 1, and I'll multiply by 3. So 1 times 3 is 3. So then I go 3 times 3 is 9. It's 27. 51. No. 27 times 3. 81. 81 times 3, well 8 times 3 is 24. So 80 times 3 is 240 plus 1 times 3 is 243. And then 243 times 3, 200 times 3 is 600. 40 times 3 is 120. And 3 times 3 is 9. So 600 plus 120 is 720 plus 9 is 729. And a sketch of that would be like this. And then a quadratic pattern, remember the second difference is the same. So I'm just going to do a square. I'm going to do it squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, because quadratic means x squared. So 16, 25, 6 times 6 is 36, and 7 times 7 is 49. I know that this is quadratic because it goes up 3, and then 5, and then 7, and then 9, and then 11, and then 13. And then the second difference each time is 2. And this is going to be a parabola. It's going to be the parabola y equals x squared, which looks like that. So then how do I know? So for the linear pattern, I know it's linear because the table goes up by the same amount each time. The first difference in the table is constant. It goes up by the same amount each time. For the exponential, I know it's exponential because it multiplies by the same amount each time. And then for the quadratic, I know it's a quadratic because the second difference is constant. Alex is keeping track of how many miles per gallon his car can travel. He records data from several of his car trips below. So, let's see, if he goes from 40 to 120, I'm going to divide. Well, I noticed that this 40 times 3 is 120. 60 times 3 is 180. So I'm going to assume that the table keeps going like that. 50 times 3 would be 150. This would be 90. 20 times 3 is 60. 10 times 3 is 30. 0 times 3 is 0. What is the miles per gallon of Alex's car? That is, how many miles can he drive on 1 gallon of gas? So to find that, that's the unit rate. We would need to divide. So if he drives 30 miles per 10 gallons, if I divide that, that equals 3 miles per 1 gallon. That's really bad. 3 miles per gallon.